Hi, I've got a new book here for you. This is Gary Zacharias, and this is the Apologist bookshelf. Well, it's not brand new. It's maybe 2 years old, but seemed new to me. It's called A Good and True Story by Paul Gould, subtitled 11 Clues to Understanding Our Universe and Your Place in It. So when I get a new book, I like to look in the back just to see what people have said on the back cover. And people like Mary Jo Sharp, Paul Copan, Melissa Cain Travis all give it a thumbs up. But the person I was really impressed with, who gives us a huge thumbs up, is J.P. Moreland. And what a thinker, what a writer. Here's what Moreland said, talking about Paul's book. Very accessible, conversational, full of stories and illustrations. Well, that's a nice comment. But he goes beyond that. He says, this is now the best book to give to an unbelieving friend or relative. Now that is high praise coming from J.P. Moreland. The best book to give to an unbelieving friend or relative. Well, let me show you what he's up to here. I'm going to go kind of toward the middle of the book. He's talking about the history of life on Earth and the beginning of life. So he says, we've got a story of expansion and diversification. We have creatures that come, and they, for a long period of time, life on Earth is sparse and simple. And he says, roughly, let's pick up the story about 3.5 billion years ago. You had an atmosphere of carbon dioxide, methane, sulfur dioxide, and nitrogen. There wasn't much oxygen. And then about 2.4 billion years ago, about a billion years after the first life formed, the atmosphere began to change. And the level of oxygen increased and kept on going. And the next step after that, then you get, of course, at that time, with more oxygen, you got more complex multicell organisms. The next step was organisms with skeletons. They began to appear, he says about 500 million years ago during a period known as the Cambrian explosion. And that witnessed an abrupt change. I mean, all sorts of new body types and animal groups just appeared within just a few million years. And I know when we say just a few million years, but it's odd, but with evolution, it's not supposed to happen that fast. So they call it an explosion. And you get water-dwelling animals at that time, sea worms, arthropods, mollusks. And then around 450 million years ago, the land began to be green, and now you got soil developing, and you get more biodiversity. And you've gotten a lot of species that are just blooming on Earth. But then about 250 million years ago, it was called the Permian period, a lot of species died out, maybe a lot of volcanic activity, and then we get more diversity coming back in about 100 million years ago. We got the dinosaurs 65 million years ago, probably ended when a meteorite hit the Earth. And after all of that information, Gould says 2 lessons can be drawn. One, it's a dramatic story, a world kind of waking up. It's got stops and starts and plot twists. And he says the staggering diversity of life is evocative. How did this diversity of life originate? And that's going to be the key question that he wants to deal with. So he goes to Darwin. In 1859, he came out with On the Origin of Species by Means of Natural Selection. And the answer was, how did we get life? Evolution. That's how you get diversity of life. That there's some kind of unbroken chain of living organisms that start simple and move to complex. They all had a common ancestor that had it started in a prebiotic soup, something like 3 billion years ago. And said just about everybody believes that today, at least according to some evolutionists, that that's the basic explanation, and we've got it all figured out. And it said, but if you take a look, it says, let's look at genetics. Let's take a fresh look at the evidence to see if evolution really is the best explanation. So they're going to look at genetics. So natural selection basically determines whether or not the genetic code for these variations in the animals will survive. So what happens is, it's called the neo-Darwinian synthesis, that there's going to be an inheritance. These animals will have some characteristics that will help them, because of natural selection, adapt to their environment. They'll live, and they'll pass that along to the next generation. But now here comes the rub when it comes to the evolutionary view. Molecular biology now has cast doubts on whether selection and mutation are powerful enough to give you a diversity of life. Why? because you've got functional information within all forms of life. And the problem for the neo-Darwinist is the problem of where are we getting this new biological information? So if you have natural selection that acts on random mutations, that doesn't produce the kind of information you need to build new animal forms. So it says new body plans require new cell types. And those new cell types need proteins, functional proteins. Now, how do you get the proteins? You need new genetic information, kind of like a blueprint. And so the idea from the Darwinist perspective is genetic information is generated by just random unguided mutations in existing organisms. Well, Gould said there's some problems with this. First, natural selection only acts on whatever is there already. It can't invent new species. So selection only preserves innovation within the species that's already there. That's a gaping hole in evolutionary theory. In fact, somebody once said, Darwinism may explain the survival of the fittest, but it can't explain the arrival of the fittest. I think that's a great line. So Gould says the invention must lie someplace else. And how do you get accidental invention of new functional proteins? By random mutation. He said it's really unlikely. It's rare to get the arrangements of DNA bases that will produce new functional proteins. So the problem is, how do you get a new sequence that will code for just one protein? But you need a lot of proteins to generate new body plans and new species. He says many biologists actually are going to admit that this natural selection can't be the whole story. It doesn't have creative power. It can't generate that new biological information that you need for new body plans. In fact, I guess there are two biologists here. They say, well, they still like the neo-Darwinian paradigm, but it completely avoids the origination of traits and forms. It doesn't have any theory of the generative. In other words, how do you get it going? How do you get it started? You can keep it going, but how do you get it started? And so he said, we have no information yet on any kind of proposed method to get this novel new information going. He said, what's the best explanation for the origin of species? I mean, what accounts for this explosion of novel body plans and information throughout the history of life on Earth? He said, intelligence. He said, we're led through the investigation to an intelligent cause. And he says, why bother with long, drawn-out discussion about evolution? He said, we want to discover the true story. He said, there's a widespread belief that evolution is the best explanation. So he said, let's not leave any stone unturned. He said, yeah, he agrees right now the debate over the origin of species has become pretty toxic. But he says his claim is that evolution only works if you can produce all this new information. There has to be a mind, he says, behind that to get that evolution. He says individual organisms have to adapt. And how do they adapt? They've got to have that new information. And so he said, the evidence from science points to an intelligence beyond the physical nature as the physical universe as the best explanation. He says that's startling. He says Darwin did not explain away design. So he's going to continue with other sections of the book here. But I just wanted to give you a feeling for what he's talking about, this species thing. Now let me share with you just one other chapter here. This is a chapter about life itself. How do you get life going? How do you get it started? He said, well, people are pretty optimistic. You know, the naturalists say, well, we'll figure out how life got started. But James Tour, who's a professor at Rice, he's one of the world's leading synthetic organic chemists. And he said, we synthetic chemists should state the obvious. The appearance of life on Earth is a mystery. We're nowhere near solving the problem. Is life unique? Is there a divine cause, he asks? Or is it just something that happened with these blind, purposeless forces? And he says, think about this. People say, well, the Earth's been around for 4.5 billion years, or 3 billion, whatever it is. Obviously, that gives you plenty of time to get life started accidentally. But he says, oh no, for the first 700 million years or so, the Earth was way too hot to support life. And he said they're already finding fossilized stromatolites. He said actually in Greenland now, they date back to 3.7 billion years old. Now, if the Earth is maybe, I don't know, would he say 3.8 or so, you've got roughly 100 million years to get life started. That's a blink of the eye when it comes to geologic time. And you got to get proteins and a DNA and RNA and metabolic systems started. Where was it on Earth that life began? He said, well, Darwin said some kind of warm pond. Others have said maybe deep sea thermal vents, that maybe there, edge of the ocean, the edge of volcanoes. And some people have been so frustrated with this, they say maybe life came to Earth from somewhere else. Like maybe it came by asteroids or maybe intelligent beings. Francis Crick, Stephen Hawking actually have pushed that. But of course, that doesn't solve your problem, does it? If life didn't originate on Earth, how did it get started in space or some other planet? There's no evidence at all, he says, by the way, of any biological life on beyond Earth. So he said we got two problems here. We got the ingredients. How do you build the basic building blocks of life? How do they come out of natural processes? And then once you've got them, how do you assemble them in the right sequence? So he said the ingredients, you've got to have proteins, genetic material, DNA and RNA, and lipids, cell membranes. And he said they've got no idea how those things started. Now, Harold Urey and Stanley Miller tried something back in the 50s called the Miller-Urey experiment of putting gases and hitting them with a spark. And they did get some basic amino acids, but they've given up. That isn't the way people think the early Earth atmosphere was. So they said, by the way they even got that stuff was in a highly regulated environment of the lab. And it says there's been no real success. And he stresses this, no real success in producing building blocks themselves. Now, they got some of the subparts of the building blocks, but they haven't come up with proteins. They haven't been able to make those happen, or DNA or RNA or lipids. He says next up is the assembly problem. So now you got these things sitting around, DNA or proteins or something. But he says, think about single-celled animals. They were one time thought really simple, but now with better microscopes and all, they look at them, they say, wow, they have so many subsystems. They're molecular machines in there. Somebody said the cell is like a human factory. Now it says, for example, let's take proteins, right? Cells are made up of proteins and other microscopic parts. How do you get proteins? You take amino acids, you hook them together in a chain. But it's got to fold a certain way. And it said the biological information inside just a simple organism is mind-boggling. Even in a basic single-cell organism, you need something like 300 to 500,000 of base pairs of DNA. Now, the human genome has over 3 billion pairs. So here's the question. How did the first cell get these genes, that's the information, how did they get the blueprint necessary for life in the first place? And people have done all sorts of research on it. He mentions Doug Axe. You might look him up. He's a biologist. And he said, that's A-X-E, his last name. And he's got a book out, and he talks about how do you get functional proteins? It's so rare to be basically impossible. So toward the end of this chapter, he says, we've discovered that the time span for life to come up by natural processes on Earth, it's really short, geologically speaking, and they haven't figured out where this prebiotic soup was located. Now he says organic chemists have had some success in producing some of the beginnings of necessity for life, but they have no success at all producing the basic building blocks, proteins and DNA and RNA and lipids. So he said, at that point, can we say there is a divine cause if we're not going to buy into evolution? He said not directly, but he said we could argue from the fact that life seems to be a product of non-natural processes to the conclusion that what's the best explanation for non-natural processes? God. Yeah, I think that's a really good point. So I hope you find this to be an interesting book. I hope the science wasn't too much, but I think that's really fascinating. So the book again, A Good and True Story. Paul Gould is the author. Thank you for being part of this podcast. Hope you're having a good day. Talk to you later.